So as I start today, I want to start with this multiple choice question. So this deals with compound interest, and with compound interest, we always have the formula initial times 1 plus I to the power of n. And I want you guys to start by trying to answer this question. What do we think the answer is? If we start with 8,800, we have 3 years, and we compound it annually, which means we add the interest once a year. What do you think we're going to get? I'll give you some time for that. Well, we know we start with that. We know the n, because it's annually, there's 3 annuals or 3 years here. The difficult part is the interest, and you can either write it as 7.5 over 100, or you can write it as 0.075. And in that case, you should be getting an answer of D. So it's going to be 10,932.21. Now, what I want you to notice is that the word compounded annually is important, because that means that you add interest to the principal. So there's the principal, and you add some interest at the end of the first year. And then what happens is you add some interest at the end of the second year, and you add some interest at the end of the third year, and then you get your final A value. Okay, so it means once a year. Now, if it wasn't a yearly compounding, then we would have to change we have to adapt the equation. But I think so far, things were looking good. So let's look on to the second question. Now, notice how we're talking about interest, but we're focusing on compound interest. So in this thing, it says, what is the value of 9,800 after 4 years if it is invested at 6% per annum compounded quarterly? Now, before you even answer this, I want either some audio comments or some comments in the chat about what is different about this question compared to the last one. So put your hand up if you feel like you can share some of your wisdom with us, or put it in the chat, and I can give you a shout out, or I can give you some acknowledgement. Let's go to Keisha. Keisha, what do you think is important to consider in this situation?
Hi, sir.
Hey.
So, in this question, it says quarterly, which is different with the other one because it said annually.
Yes. Okay. So how does that affect? I assume it's the same formula. How does that affect? I wonder, how does it affect this formula here? How many, if I have to go and get n, what is the n going to be in this question? So it says 4 years, but I don't think it's going to be 4. I think there's going to be a different value up here. Masejo, let's go to you.
Hello, sir.
Hey.
So I think it's going to be 4 times 4, because quarterly means 4, obviously. So
yes,
it's going to be 4 years time. So then the n is going to be 16.
Perfect. So we've got 16 quarters in 4 years. Now, while I've got you, could you help us with interest rates? Could you help us with the interest rates? I'm just going to mute all, then I'll unmute Masejo. So there we go. Hi, Masejo.
So it's going to be, it's going to be, well, the way I learned it at school is going to be 0.06 over 4.
Perfect.
4 because of the compounded quarterly.
Yeah, because you're cutting the interest rate into a quarterly interest rate. So you're matching the interest rate and the time periods. They're both in quarters. Okay. Now, what is the answer going to be if I do this whole calculation? I've got 9,800 times 1 plus 4 to the power of 16. Now, let me actually get my calculator. What are we getting for the answer here? Actually, I'm going to go grab my calculator. It's on my table. For some reason, my calculator has left the building. But let's see. I see most of us are getting to A. So what do we have here? Yeah, we're getting A. Okay. So the only thing that you could get wrong is if you left out the divided by 4. And so in this case, you will get A as your answer. Give me a thumbs up if you're following this. Give me a thumbs down if you're feeling unsure anyway at this stage. Here, just to check you all back. Okay, I see you in the thing. That's cool. Okay. All right, everyone. Let's go on to a slightly different type of question. So in this question, it says, it's a little, in fact, I want to ask you to identify. It says, at what interest rate should you invest 5,000 if you want to double your money in 6 years? And before we do the question, I want us to spot what is different about this question. What is different about this question compared to the last one? Take a moment to read it. At what interest rate should you invest 5,000 if you want to double your money in 6 years? So Morgan has said you've got A and P. Now, your P value is going to be 5,000. And I think what Morgan has realized is that double 5,000 would be 10,000. Okay. Now, Mbali and Zanelli said it's not compounded. So you're right. It hasn't said that. The assumption would be, though, if they don't say anything, you would assume it's compounded interest because that's the one that's the most applicable in the real world, but very good spot. So we don't know what the interest rate is. Do we know what the N is? Do we know what the N is? Okay. I think the N is 6. Now, if we look at our formula normally looks like this. So I think we can fill in that this is 10,000, that this is 5,000, and that this is going to be 6. Now we have a bit of a problem. We still want to find the answer, right? But how do we get that answer? Because the I is trapped inside the bracket. So who feels like they might have an idea of how to get at that I? What can we do here? Ideas? Yes, Annie. Divide both sides by 5,000. And if you do that, so if you had a 5,000 here and a 5,000 there, it would cancel out and we would get 2 equals 1 plus I to the power of 6. But we've got another problem now. What do we do to get rid of the 6? What undoes to the power of 6? It is the 6th root, yes. So in your calculators, you do that, and you do that. And on this side now, you have 1 plus I. What do we get when we ask the calculator to give us the 6th root of 2? Give me all the decimals, or give me all the roots, or whatever it is that you get in your calculators. What do we get? It's like a nice messy one. It'll be 1 point something something. Now, it can't be 8 point because it's the 6th root. So you must go next to, if you look at your calculator, there's a button which has like, it looks like this and like this. And you want to put a 2 in here and a 6 over there. So I'm seeing 1, 2, 2, 4, 6, 2, 0, 4, 8. And if you want to solve for I, all you need to do is take 1 away from both sides. And so what we get is we are going to get, so take away 1 from both sides to get I, we are going to get 0.122462048. Now, everyone, what I'm spotting is if I wrote this as a percentage, it would be 12.24%. Now, actually, none of the answers are exactly that. So which one do we think is closest? Which one? Because it's actually not correct. There's not the correct option. But what there is one that's closest. Which one do we think is closest here? Okay, Annie has put her answer on the board there. Yeah, so the one that looks closest to me is 13.04. So this question, it actually isn't an exact question, but it's mainly the logic that I wanted to. Now, this is harder than the last one because I divided by 5,000 and then I had to take the 6th root of both sides. Give me a thumbs up if you followed that. Give me a thumbs down if you didn't follow that. Just want to get a feel for the mood in the room. Because sometimes we have to be able to solve for A and P and I and N. And what we just did now was we solved for the interest rate. And so this interest rate would be per annum. Okay, so you would get 12% per annum. And if you got 12.24% per annum, your 5,000 Rand would double in 6 years. That's what it means. Okay, it's quite a lot. Add 12% interest and you double your money that quickly. Okay, now let us do another multiple choice question. Let us do this one. Let me move the other ones out the way. And this is a slightly different question, but the only difference comes, but I want you to do it, is this part. And I want you to adjust that while I go and look for my calculator. I found it. So which of these 4 options do we think? Okay, so what I see is that we have to make sure our interest rate, which is per month, matches the units of time, which are also in months. And so if we do that, we seem to be getting 11,012.73, and that is going to be rands. So this is what we call compounding interest over different intervals. We are changing how often we basically add interest to the main bit in the bank. Okay, so C is the correct answer. C. Well done, Neo and Bianca. That's looking good. Okay, well, you guys are doing so well. I want to keep swimming with this. So let's do this one. So how much money should Amy invest at 11% per year, so per annum, if she needs 25,000 in 5 years' time? And the default assumption here is that you're dealing with compound interest. See if you can figure out that one. We need P, exactly, Morgan. I'm taking you through all the combinations. We solved for A, we've solved for I. Now, we won't actually solve for N that often because N, we need something called logs, but that will come around in matric. Or if we do solve for N, it will be like a simple one. Let's see if you can do this. Keep those answers coming when you think you have. I'm going to start by writing down my information. I feel like that is what I have. And what I want to get at is what is the original amount here? The good news is I know my equations, and I think I can just move this whole thing to the other side. And at the moment it's being multiplied, which means if I bring it across, it's just going to be divided to get P. Now, what do we think the answer is? Well, let me try it on my calculator. 25,000 divided by 111 to the power of 5. And I get 14836. 14836.28, which to me looks like the answer B. Well, it is the answer B. So you have to start off with that much in the bank. And if it grows at 11% per year, it will get to 25,000 in 5 years' time. So from my point of view and looking at the chat, things are looking good. Quick thumbs up if you're feeling good. Quick thumbs down if you're not feeling like, if you're feeling like I'm running away with things and not giving you sufficient time. Please do voice your opinion in the chat with your thumbs. Let your fingers do the talking. Fantastic. Okay. Well, then what I think we need to do is we're going to do a little comparison question. So what we're going to do now is we're given two different deals, right? Two different options. And both options start with 10,000 Rand in the bank. And they stay there for 2 years. But option number A, we want to know the final amount with these conditions. And then option B, we want to know their final amount for these conditions. Can you work out for me the answers for A and B? And I will give you this statement. There are 52 weeks in a year. So you don't need to go and Google that. I will tell you there are 52 weeks in a year to help you in case you're worried about compounding weekly. All right, off you go. I want you to ask me questions if I'm confusing you or if I've let you swim too soon. But for now, from what I've seen in the chat, I think you're ready for this. You can just pop your answers in the chat when you're ready. Now, dividing that by, we actually need, if there's 52 weeks in a year, we need to divide this by 52. So that's kind of different, I guess. And then on the time, well, how many years? It was 2 years and it's quarters. So this is going to be 8, or 2 times 4. What's this going to be up here? Well, it's got to be double 52. So that's going to be 104. Now, what are we going to end up with? Well, I don't even know what we're going to end up with. I need to do the maths. So 1 plus 0.05 over 52. And then to the power of, make sure you're keying in this correctly, 104. I get, let's hope everyone agrees with me, 11051.17118, or 11,051.18. And for this one, open bracket, 1 plus 0.15 over 4 to the power of 8. And that is going to be 13,424.71. So out of the two options, it's clear that this ends up with a much bigger amount. But that also is because this is 15% compounded quarterly, whereas that, that's 5% compounded weekly. So that, that kind of makes logical sense to me. All right, I like it, Liliche. I think we're all on the right page with this, and we're making good progress. Now, what maths teachers love to do every now and again is just throw in a discount or like general financial maths question. So could you work out what this one is? This is just a general financial maths question that can come up at any time. See if you can, okay. Before I jump ahead, let me go back and explain. So I'm going to leave this question up on the board while I explain. There's been a good question come through. How did we get 104? Well, we said this journey is for 2 years, but remember there's 52 weeks in each year. And so we go 52 times 2 to get 104. The same way for this one, it's compounded quarterly. We went 2 times 4 to get the 8. Okay, so I hope that helps. Okay. So, people are going for B. Let's have a look here. Do I think it's B? Do I think it's C? Well, it says you have a pair of jeans and they are 260 Rand, and that how much would you pay? Okay, it's a discount. All right, well, to find 15% of that, I could work out 260 times 0.15, and I would get 39, and then I would have to go 260 minus 39, and that would give me 221. Or for the real sneaky ones amongst you, what you could do is times this by 0.85, and what that would do is that would also give us the same answer, which is 221. And so whenever they say markup or discount, it's important that you can carry out this sort of calculation, and it's just going to be 221, which is C. Okay, it's almost break time, not quite yet though. What I want to do is I want to do 2 little calculations before we go for our break. There's 2 situations. The one situation, we are going to start with a value of...
So where does the 0.85 come from?
Oh, okay. 0.85. So the 0.85, basically, if you have 100%, right, and you take away 15%, that's the same as saying 1 minus 0.15, which is 0.85. And so it's basically just a quick way of getting the new price. Otherwise, what you could do is you could find the 15%, which is here, and I took it away from the original. So you don't have to do this way over here. I'm just showing you, sometimes people do it in different ways. Give me a thumbs up if you understand you don't have to do it this way. You can do it this way. In fact, most people would have done it this way. I'm just, giving you some observations as I go. Fantastic. Yeah. Pleasure, man. Thanks for the question. So before we have our break, I want to give you two situations. So the situation is going to be as follows. You've got 12,000 Rand in the bank, and you're going to let it grow for 3 years. And option number one is that you are given an interest rate of, let's say, 12%, and it is compounded monthly. In fact, let's make it, why not? Let's just make it 12% compounded monthly. So that's option number one. Option number two is that you have the same information, 12,003, but your interest rate is 12% and it is compounded quarterly. So I'll put the information here. So N is 3 years. I want you to work out how much money you end up with in option one and how much money you end up with in option two. And just ask for clarification if you're unsure about what I'm asking. I'm saying there's two situations. You start with 12,000 Rand. You have 3 years to grow the money. But the one is compounded monthly. The other one is compounded quarterly. And I want you to work out how much ends up in each account. See what you get as your answers. So what are we getting for each of these? So for A, it seems like we are getting 17,169. Let's use blue. 17,169.23. What about for option two? What are we getting for option two? It seems like for option two, we're getting 17,109.13. Now, what I want to ask you is which option would you prefer, option one or option two? If I look at this on face value, there's a 12% here and a 12% here. There's a 12,000 here. There's a 12,000 here. There's a 3 years here. There's a 3 years here. Which option would you choose? They look so the same. Okay. The option number one is the preferred option because it is a bigger amount of money. So this is 17,169. This is 17,109. This is about 60 Rand bigger. Now, I want to ask you, why is this one bigger when so much of this question is the same? Does anybody know why the one on the left is bigger? Because what's causing it to get more money? Okay, Brooklyn and Annie, it's The compounded monthly, yes. So if we look at the compounding periods, this is compounded monthly, and this one over here is compounded quarterly. And what happens is if your compounding periods are more regular, or if you have more times that you add the interest to the lump sum, you're going to end up with more money. And we would say that actually over here, we say that the effective interest rate is higher. The effective interest rate is higher here because there are more compounding periods. So as you get more and more compounding periods, the effective interest rate will get higher. And so in the second part of the lesson today, I'm going to show you how to calculate the effective interest rate for different compounding periods. But all I want to ask for is a vote, is thumbs up if you understand that the option 1 is bigger than option 2, and that the smaller compounding periods is what is causing it to be bigger. So give me a thumbs up if you understand that. Give me a thumbs down if you don't get that. Okay, so that's going to be part 2 of today's lesson, where we talk about the effective interest rate. How do we know how much more the effective interest rate is higher for this option than this one? But before that, we must have a break, because we are humans and we're not built to sit for long periods of time. So I want you on your feet. I want to see your faces. I want your cameras on, and I want to see you just shaking your arms around. Just make them nice and limp like licorice, and wave them around. Wave around your feet, your legs. Maybe stretch your neck a little bit. My neck is feeling a bit stiff from all my marking today. Give your neck a stretch. Swing those shoulders. Okay. Let's roll the shoulders back a little bit. Roll the shoulders forward a little bit. And then let's do some rotation. Okay. Then we want to do some heart rate stuff. And just a quick one today. We're going to do 20 air skips. We start in 3, 2, 1. Let's go. Okay, 5 more. And that is it. I hope that you feel your body talking to you. And then here is a Maths 24 puzzle question. Who can solve it? Who can solve the puzzle question? Go Team A. Indeed. Okay. What about this? How do we get to 24 here? So Tegavatso, 3 plus 3 is 6. 6 times 4 times 1 is 24. To you goes the glory, Tegavatso. Well done. And Sanilisiwe, not far behind. Also completely legitimate, but slightly different way of doing it. 3 times 4 is 12. Times 3 minus 1 is 24. And I see, there's been plenty of ways. So we have smashed A. Now it's time to see, can you do the blue one? Can you do the blue one? Don't worry, Anda. Unfortunately, that happens with load shedding and such things. How do we do the blue one? That's a 6, huh? Well, I know that could be helpful. What else do we have to do? So I think we've used 7 and we've used 4. Oh, wait, 7 times 2 plus 6, 7 times 2 plus 6 plus 4 gets me to 24. Absolutely. And then my way was going to be 7 minus 4 is 3 times 6 plus 2, which is also 24. And I see quite a few students also got that. Okay, well done, everyone. I hope you had a good break. Let's return to our lesson. Okay, what I want to show you, before my screen goes crazy, is I want to talk about effective interest rates. Okay, so I need a formula here's a question from an old exam. What is the effective interest rate? And then we'll go on to the other ones later. What is the effective interest rate if your calculation is 7.5% per annum is calculated monthly? So this is the formula that we use to compare the nominal rate and the compounding periods. Let me just write it out for you first before okay, so we get 1 plus, I talk about I nom and I effective. So if we start with this formula, there's a couple of different pieces that we need to know about. The effective interest rate is going to be per annum. All right. The nominal rate is going to be per annum, but it's chopped up into pieces. First of all, what do we think the M is going to be given the way this question is phrased?
Months.
Months, monthly. Okay. Now, what number is associated with months? So we're going to get, so INOM is going to be 0.075, or we could say 7.5 over 100, and we're going to divide it by 12. But now this over here is also going to be a 12 because it's the same M, and then there's a -1. Now I want to ask, what do you get if you put that into your calculator? So if you put this whole sequence into your calculator, what do you get? So you should get a whole bunch of like 0 point something, 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 because there's a -1 at the end, huh? So you should get 0 point blah, 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 blah. I want to see what you get. So we should get all these messy decimals, 259,776. You can keep them in memory. And normally we write them as a percentage. And if there's a percentage, we times it by 100 and we get 7.76% per annum. So this is the effective rate. Because what you'll notice is that the effective rate is higher than the nominal rate. Now, why is the nominal rate, smaller than the effective rate? Well, because you've chopped up a yearly interest rate into months. And so because you're adding a little bit of interest every month, it grows effectively at a faster rate. And so you'll always notice that the effective rate will be higher than the nominal rate because of those effects of chopping it up into smaller pieces. So let me just point that out. Your base rate was that. Your effective rate was a bit higher because the chopping up is helping us get a higher effective rate. And this happened in the previous example too. Now, give me a thumbs up if you could read this formula and you followed the logic of it. We need to practice it, but I just want to check if you followed the main idea. what the effective rate does is it takes into account the various effective rates you get when the compounding periods are different. Like you could have had a monthly or a quarterly or, etc. So let's try this. I want to know what is the effective rate, and I'll write the formula up now, for this compounded monthly. So I want to do that one. I want to know this compounded weekly. Let's start with those two. And the formula that I will give you is this, where M is the number associated with the compounding interval. And you are going to do A and you are going to do B for me. And you're going to tell me what is the effective rate that you get. Let me do them in different colors so you... Okay, so what are we getting? Put your answers in the chat if you feel like you... Yeehaw. Yeah, so I get, for this one, 0.12734009, and so on, which is going to be 12.73% per annum effective rate. And then for the green one, compounded monthly, I'm going to get 1 plus 0.076 over 12 to the power of 12 minus 1 plus power of 12 minus 1, and I get that's 0.078704 and so on, which gives us 7.87% per annum. Okay, now again, what you notice is it's a little bit higher than the 7.6% here, and here it's a little bit higher as well. And that's because you're chopping it up into smaller pieces. Okay, I want us to probably finish today with these two. I want to do semi-annually, which means every 6 months, compared to this one compounded quarterly. What are the effective interest rates that you get from compounding like this? No problem, Rita Bukhari. I will see you on Monday. I hope you have a good rest of the week. Just do your quiz within the next 24 hours. Okay, so we're doing D and we're doing E to get effective interest rates. So for semi-annually, what you do is you write 2 because it's twice a year. Because if you think about like monthly is 12, quarterly is 4, semi-annually is twice a year. Yeah, so we get 4.45% per annum for D. And then let's try and do E. And we are getting 8.03 effective rate % per annum. Okay, so why have we been doing this effective rate thing? Well, it allows us to see the effect of the different compounding periods. And sometimes it allows us to compare different rates on the same basis. And so it's effectively, what are they working out to be? But the main story of the second part of the lesson that I want you to remember is that the formula for converting from a nominal rate to an effective rate, and I don't think that this actually isn't on the formula sheet, so you need to make sure that you've kind of memorized it over time, or at least remember how it works, is going to be that. And so I want you to kind of, that will take a nominal rate that's chopped up into pieces and give you the effective yearly rate. Okay, I think it's a nice place to end for tonight. So